What's going on, guys? Welcome back to another one of the videos. Today we're going to be actually looking or doing another another kind of nice little treat in the direction of forces and torques, right? So maybe just a quick revision for you guys. A torque, right? We say M is equal to a force times some length or some distance, right? So M is F times D, and F is M times A, mass times acceleration. Great. Let's say Alright guys, so here is our, well, basically what we're gonna calculate, and it looks kind of crazy, but trust me, this is very simple, right? We've already done this. This is just kind of a quick revision. So we have F1 is 100 Newton, F2 is 200 Newton, F3 is 300, F4 is 400, and so on and so forth, right? So now some of you guys might say, what I think I did not explain in the last video is why we even want to know what forces these bearings have, right? And that's a great question. Well, we have to know what forces the bearings have to actually calculate how big the bearings have to be, right? Because when we have bearings, they also have a certain capacity, right? They have to be bigger to carry more load, or they have to be made out of a different material to carry more load. And this is basically what we calculate here in the most simple way, in the simplest way, right? Okay, so I'm just going to move this up a little bit here. This was 2. Okay, let's do it now. So, first step, guys, as always, is to only have the forces, right? So I'm actually going to make a 1 here because I actually drew it kind of badly right in the middle, okay? So 1 is going to be here, 2 is going to be here, right? So this is the first step, this is the second step. So now actually what we do is we take the forces right as they are, and yeah, we just basically copy them down, right? Unless one thing is different. F2 and F3, as you guys have learned, F2, right, is the same as F2x plus F2y in vector form. Or you could say that F2, because F2x and F2y share a right angle, which means that you can say that F2 is or F2 squared is the same as F2x squared plus F2y squared. Okay, that's just an aside note because we've already learned this. Good. So now splitting this up, right, we have F2y, and in this direction we have F2x. Great. Here we have F1, and here we have F3, F3y, and of course F3x. Now, important guys, I did forget one thing. That was not only to write F4 here, but also we also have the bearings, guys. Keep that in mind, right? The bearings have to carry some load, so that means that we also have to draw some forces for the bearings. And now, now you guys might say that which of the two bearings is our bearing which can carry both X and Y loads? It's of course this one, right? Because this one is as if it were rolling on rolls, right? It can only carry forces from the Y direction, of course, or in the other direction, of course, right? So yeah, so we have to now make an assumption as to are these bearings gonna have to take a force from the top or from the bottom, and this bearing is it gonna have to take a force from the left or from the right? Well, knowing that the angle alpha is 60 degrees and this force is bigger than this force. So further on, right, this force has to be bigger than this force, which means that the bearing has to have a force which is going to be pointing towards the left side. Okay, so anyways, you know, maybe you guys remember, right, last time we actually said that it does not really matter in which direction you draw these forces, because if there's a negative sign in the calculation, that means you drew it in the wrong way, and you have to flip it by 180 degrees. Great. Now I'm also going to assume, although this is not very clear, but I'm just going to assume that this bearing is pointing, because all the forces are pointing from the top, so I'm thinking that it's going to be a force from the bottom. Okay, so we got FBY here, and then we got, at the same level as this, we got our force right here. I think it's going to be from the top, because there's very little distance from these two things, right? So I think it's just going to be FA. No YRB needed, because, of course, this bearing can only take forces from the top or the bottom. We could theoretically draw an FBY, but that would have to be 0, and we would have to basically just, once we write down the axiom is of course just sum of all forces and sum of all torques is 0, but once we did that, it would just be plus 0, which just cancels out, so it does not really matter, right? Okay, so now that we've got this, maybe we continue, okay? So what is the first step when doing this? Well, the first step is saying, maybe the first step, if I had to do this again in school, maybe the first step would just be to calculate out what is F2x and F2y, F3x and F3y, okay? So let's have a look. The way that I do this, to make this really simple, right? I just say, I take the F2 vector as it is. I don't even do anything with it. Okay, so I just take the F2 vector here as it is and write F2. That's it, all I do. And then I just say, okay, if F2 is pointing this way, right? Which forces have to be, or which way do the forces have to be pointing, and how does this have to look for it to actually make sense, right? And if we can only have forces in the y and the x direction, now of course it must be like this, right? With a y angle, with a right angle, sorry about that, F2y, and of course here is F2x. Okay, and this is of course a right angle. Good. Now let's have a look at how we can calculate the y and x forces, right? We have the angle alpha in here, okay? So let's see. So we can of course say sine, right, of alpha is the same as F2 y in this instance, so because it's the opposite side divided by the hypotenuse, right? So we have F2y all over F2, and we can say F2y must be the same as sine of alpha times F2. Great. And of course we can do the same thing, but we just have to use cosine this time, so we just say F2x is cosine of alpha times F2, right? Now, you guys already know, I like to use 30 and 60 degrees because those are the angles at which one of the two functions is 0.5. And in this case, you guys might have guessed it, or you guys knew it, of course, because you've been paying attention. It is 0.5 times F2, right? Because the cosine of the angle alpha is just the same as 0.5. Okay, good. And now we can do the same thing with F3y and F3x. I would maybe draw it like this again, right? It's not really needed, but when you're a beginner in mechanics, then it really does make sense to draw it like this, because you just get the practice in, right? Let me just do it a little bit on the slower side, right? So that doesn't really bother me. Okay, so we have the three forces, F2y, F2x, and F2. Now guys, keep in mind, one thing that I also wanted to mention, keep in mind that I'm not writing any minuses here. Although both of these forces are pointing in a negative direction, we are going to account for that when we will say that the sum of all forces and sum of all moments must be 0, right? We are going to account for that. But right now, what is important is only to draw the forces in as if they all were positive, right? Of course, in the respective direction, but treat the forces as if there were a plus everywhere. Because the direction of this arrow is actually determining whether or not it's actually negative or positive, right? Okay, I hope that makes sense for you guys. Good. So, we can just do the same thing, right? Of course, we have the angle here. So, yeah, I mean, let's write it down. I'm just going to do this very fast. F2y times sine of 60 is F2 times sine of 60 is F2y, and F2 times 0.5 is F2x. Great. Now I'm going to plug that into the calculator. Alrighty guys, so I just realized, of course, this was all 2. This is of course 3, right? We were treating F3 where we're looking at F3 right there. So F3, F3, F3 everywhere. Here's F3 and this was F2 of course. So these are the results for F3 and these are the results for F2. Good. I'm going to clean up this board a little bit. Alright guys, so did a little bit of cleaning up. Now we have the forces here and let's actually have a look. So most important thing guys to know is that we are in statics, right? Which means that we have our 3 conditions for solving this is number 1 is, or let me actually not do it like this, let me do it like this. Number 1 is that the sum, okay, of all forces in the x direction must be equal to 0, which are further equal to. Number 2 is that the sum of all forces in the right direction must be equal to 0, is equal to. And then you have the third one, which is, of course, the sum of all moments around the point of choosing, let's just choose A, is equal to 0, right? Good. These are our 3 conditions for this thing to be solvable in a way that we're going to solve it, right? Good. So let's actually just have a look at this, and it seems like a lot, but again, this is very simple, very easy, okay? So let's have a look, nice and slowly, okay? So we have, again, remember, going from top to bottom, nice and slowly, don't make mistakes, that's how you're going to win the game, right? Alright, good, let's have a look. Fx is equal to 0 is x, of course, I forgot to define our system of coordinates. This is x and this is y, okay? So we have negative 2fx. This is the part where we actually consider the direction, okay? So negative 2 f2x, of course, sorry. Positive plus f3x. f3x. And then we have negative fb x. That's it, okay? You can of course write is equal to 0 again. That does not really matter, okay? Good. Let me just leave that out because we've already got that here, okay? Good. Well, let's continue. We have f1 positive because it's pointing upwards, okay? Then we have negative f2y, so minus f2y. Then we have plus fa because it's pointing upward, okay? fa. Then we have, sorry about that, we have negative f3y because it's pointing downward. Then we have positive f4 again, and then we have positive fby and negative fby, and then a negative f5. Great. Let's wait a second with the moments. Okay, let's look at the torques. Let's just wait a second. Okay, let's solve this first because this is very simple. Okay, so what do we need to find out? We need to find out fbx, right? And how do we do this? Well, this is actually simple, right? You just say that this equation, you just say plus bx, okay? So maybe let's do this very slowly, okay? So I'm gonna bring this up here, okay? negative f2x plus f3x minus fbx is 0. Okay? Now what we do is we can actually change this, because this is just an equation, right? We can say plus fbx. Okay? And now we have, on one side we have fbx is equal to, what is it equal to? Well, we don't need to multiply by -1 simply because of the fact that it's negative here, so it's going to be positive on the other side. We do not need to multiply by anything. It's just f3x minus f2x, which is the same as f3x minus f2x. 150 minus 100 is 50 newtons. And there's our first answer, guys. Not that difficult at all, right? And again, remember, what does it say that this is positive? It means that this is correctly drawn, that it's pointing towards the left in this instance, right? Good. Let's now continue on. So here we run into a bit of a problem, you guys might think, right? I mean, we don't really run into a problem, but just for now. We run into a problem, and that is that we know, okay, we know f1, we don't know f2, okay, let's just, sorry about that, we do know f2y, of course, we don't know fa, it doesn't matter, one variable is okay, right? Oh, we don't know 2 actually, well, that's a bit of a problem, right? X, we do not know fby, we do not know fa. Now, this is where the third axiom comes in, right? We have the sum of all moments must be equal to 0. And now, if we write it like this, right, we have to, this is the point A. So this is just a random point which I can put anywhere on this sketch. It does not matter, right? But the most intelligent thing, guys, if I want to calculate a force, how can I eliminate a force when calculating it with torque? And the answer to that is have it no distance from the point. Okay, so it has to be exactly on the point. So where do we set the point A? Well, we put the point A right in line with FA, so that FA has no torque, right? And this way we can eliminate this force, and all of a sudden we do not have 2 unknowns, but only 1 unknown, which is FPY, because it does have produce a torque, right? And one more thing, guys, one more question for you guys is, does F3x and F2x actually, do they produce some torque? Well, let's have a look. In line, same with FBX, in line. No, they don't. Very important. They do not, because the same as FA, they are all pointing towards or away from our point. Okay, so let's just write the axiom here. Okay. Now remember, every time that I'm doing something like this, you guys should pull out your pen and paper and do it yourself, right? This is of course I'm doing it for you guys, but it is scientifically proven that you guys learn way more from this by doing this yourselves and also calculating it yourselves. Good. Anyways, this is just on a side note. So when we have A, right, we have 2 important things to know. That going against the clock is positive and going with the clock is negative. Okay, that's important to know. Let's have a look now. So always go from left to right and from top to bottom. Okay, nice and simple, and you guys gonna take the win and gonna ace your exam. Okay, so F1 is pointing towards the top, so it's creating a torque that is turning like this around the point, which is, let's see, negative, right? So we have a minus. So minus F1, the force, of course, right? Minus F1 times the distance from the force to our point of turning. The shortest distance is 2, of course, right? So minus F1 times 2. I'm sorry, one thing I forgot is that I did not specify in which unit these lengths are, because we as technicians need to always use units, right? It is one of the most important things. So I'm just gonna write here length in meters, okay? Good. So these are all meters, okay? That makes it a little bit easier for the calculation. Yeah, let's just leave it at that. Good. So we have f1 times 2, okay? Then we have f2y, which is turning like this, right? So it's turning positively, so we have a plus there. Plus f2y times, what is the shortest distance? 0.5, of course, right? 0.5. Next one. Fa has, as we said, has no torque, so we could theoretically write plus Fa times 0. Let's actually do that. Plus Fa times 0, okay? And then we continue. Of course, we could do the same with F2x, F3x, and Fbx, but I don't have the time here. The space here, sorry about that. So, now, next one is going to be F3y, right, which is turning like this. This is with the clock, so it's going to be negative again. It's going to be F3y, and then again, we need the shortest distance, which is 1.5 meters. And then we continue, right? F4, turning around this point, okay? 4, okay, so we can see F4, but the question is positive or negative? Well, turning this way, positive. Great. Plus F4 times 4. Great. And then we have actually 2 more forces. I'm running out of space here, so I will just kind of continue writing it here, right? So we have, then again, Fby is also turning towards the positive direction, so we have plus, wait a second, I'll put it here so I don't run out of space again, plus Fby times 1.5 plus 4, which is just the same as 5.5, okay? Great. And then we have the last force, which is F5, which is turning the opposite direction, so it must be negative. We have minus F5 times 1.3 plus 1.5 plus 4. It's the same as 5.5 plus 1.3, which is the same as 6.8. Great. Minus F5 times 6.8. Okay. And guys, this is already where I'm kind of running out of space, right? So maybe you guys do this. Right, we just were called again. Maybe let me zoom in just a tad bit there. Great. So I got rid of this part, put it here, and I should maybe write what that is equal to, right? I just got a call. Anyway, so is equal to Fbx. Great. So, guys, what you need to do is, I don't have the space here, okay? But what you guys need to do now, all by yourself, is treat this as an equation. 0 is equal to this whole thing here. Okay, write that down on your sheet of paper. And then, what you want to do is, you need to find Fby, right? This is because this is the only thing that we do not know. Okay? So, what you're going to do is subtract Fby times 5.5, because this, you need to subtract the times also. Move it to the other side and then multiply everything by -1, so that every single one of these minuses and pluses basically switches. So you're gonna have here Fby is equal to F1 times 2 minus F2y times 0.5 minus F8 times 0, doesn't matter, plus F3 times 1.5, okay? And then divide everything by 5.5, and that is going to give you Fby, okay? So, when you're going to have Fby and Fbx, 2 things are going to open up. Number 1, you can calculate the whole force of Fb, right? And again, remember, if we want to know what Fb is equal to, maybe let me use another pen here. Fb, right? Fb is just the same as the square root of Fby plus Fbx squared. This is what we need, right? So, and another thing, if you get something negative from this expression, what that means is that Fby is not acting in this direction, but it's actually acting in this direction, okay? So you guys have to do that yourselves now. This is kind of an open end, okay? Good. Maybe one last thing to say. Once you have Fby, how do you calculate Fa in the simplest way possible? Okay, so you have Fby, you calculated it, okay. Now, there are 2 ways to calculate this. Number 1 is to say, okay, I put a point B here, okay? But putting a point B there means B here and then is equal to, and so on and so forth, right? Very, very, very many expressions here that you would have to write down, but one thing that we already have written down is this expression, okay? It's still long, but it's not very long, right? So, when you know FBY, actually all you need to do is, again, this is an equation, right? So what you need to do is just solve for FA and you got the answer right there. And again, if FA turns out to be negative, you need to draw FA in the other direction. Guys, I want to thank you so much for watching today. I hope you learned something from this. Mechanics is one of the most important concepts, and this might be a little bit terrible for you guys to do, actually. Not because even it's hard, but because of the fact that it is simply time consuming, right? It was the same for me when I did this in school. It was very time consuming, and I did not appreciate this at all. Maybe a little bit of a teaser for the next types of exercises like this. We're gonna learn what friction is, and we're gonna learn how to work with friction. We're gonna learn what it means if we put a block on something that is not straight, but that actually has an incline or a decline, okay? So that's actually very interesting. And again, it's nothing that one-to-one is like this in the real world, right? Because one more thing that I wanted to say today, guys, is we're treating these forces as if they were acting only in one single point, and one point has no thickness, no height, no width, right? That never happens in reality, okay? And also what we're going to learn is what if, for example, I said in the first video that somebody sits on a bench, but actually this is not what it looks like when somebody sits on a bench, right? When somebody sits on a bench, all of the little mass elements in your body spread over a certain distance, and that we're also going to learn how to calculate with that. Anyways, guys, thank you for watching. I wish you all a wonderful day and have a good one.